Now the first job is to raid the various piles of scrap metal that I have around the house. Still haven't really sorted anything out from moving yet, and I'm going to be moving again soon, so it's just kind of a bit of a mess. So we'll see what we can find. Now the project's pretty simple in and of itself from an engineering standpoint. All I have to do is weld up a nice little bracket for everything to mount onto. I can easily use the lathe to get nice interference fit on all the bearings to get everything to be held together really nicely. And I can use a 3D printer to make little enclosures and things for electronics, and really it's a very simple design. But doing all that doesn't really feel to be in the best spirit of this channel. Turns out location number 1 was just where I stored all my scrap tool steel that I was going to use for blacksmithing, so none of that's going to be very helpful today. Let's check out location at number 2. Okay, location 2, slightly less creepy than the first one, albeit not by a whole lot, but also slightly more useful. Did actually find what is actually an old weightlifting bar, a steel bar. If you've been following me for a while, you know that my whole thing is kind of just showing you that you can make pretty much whatever you like using pretty much nothing. So in the spirit of that, I'm going to set myself a little challenge for today's video and see if I can complete this entire project with the bare minimum tools, things that most of you should probably already have at home. And I haven't actually ordered any materials in preparation for this, so I'm going to be using whatever I have lying around the house. I thought this would work perfectly as the rotating arm. That then can spin around, not very well apparently, and we can attach our camera to the end of that quite nicely. Okay, now we'll actually get onto the serious part. Okay, so here we are in the workshop. This is the more genuine scrap pile, the one that I was expecting to bear the most fruits, as it were. So hopefully we can find a few pieces of sheet aluminium, things like that we can use to be able to make our little stack of various components that are going to be holding the whole thing together. So now we know roughly what materials we're going to be using. Let's get back to the drawing board and refine this design. What the to the lights. So here you can see the finished design. I designed the rotating rig to be made using some aluminium sheets I found in my scrap bin, which we made into plates to hold the various stages of the mechanism. These plates will then be held by 4 8mm threaded rods, using nuts to hold them in place. At the base you can see the black weightlifting bar, which will be used as the rotating arm to hold the camera. This will have a hole drilled through it so I can bolt a threaded rod through the centre. As you can see, the rod will be held on the bottom 2 plates via 2 flange bearings. This will then have an aluminium coupler at the top which connects this to the motor and allows it to be driven directly. 4 support rods will be screwed into this top aluminium plate, which can then be attached to the ceiling. Now, just to be clear, this is far from an ideal design for this type of device. As we'll see in a moment, this was just designed to work with whatever materials I managed to find. At the same time, I tried to minimize the amount of work that I had to do to get this up and running. Now, here are our mechanical components for the rotating rig. As I mentioned earlier, we have some scrap aluminium, some 8mm threaded rod, plain and nylock 8mm nuts, an 8mm to 10mm coupler, 2 8mm flange bearings, and our weightlifting bar for our rotating arm. The electronic components of course include our stepper motor. As you can see, this is far too large for this purpose, but it's just what I had laying around. We also have a stepper motor driver to be able to control the motor, mains power supply which will be providing the power for the motor, an Arduino Uno microcontroller which we can program to control everything, a simple LCD screen, and a potentiometer. If you don't know what all of these do, don't worry, I'm going to explain everything in a moment, but before we get into that, I've started by printing off the templates for the aluminium plates, and I'm sticking these on with a strong mix of PVA glue and water. I've experimented with loads of different ways of making accurate holes in plates over the years, and I come to the conclusion that simply printing your templates out on paper is actually the most accurate method that you can find without having access to mills and other precision machinery. So while I'm waiting for that to dry, I decided to get a start on the electronics for this. I'm just starting to lay out the hardware and working out where everything's going to go, and then I'm going to start off my software program in the Arduino IDE. I'm trying this with a 12-volt supply. I don't know if that's going to be enough to drive our large motor that we have here, so I'm going to see. I do have a 36-volt one around, it's just a little bit bigger, and I was just trying to get away with as small as possible, but we'll see how this one goes. If it's not going to give us enough torque, then we can always go up to the 36. So it's another day. Spent a good part of the evening getting electronics together, getting everything wired up and programmed. It's all a bit of a kit bash of stuff I had lying around, a motor that's way too big, a stepper driver that's probably not big enough for the motor, and a power supply that's almost certainly not big enough for the motor. But we're going to see if it works and maybe tweak it a little bit if not. Quickly going over our circuit, it's a very simple system at this stage. We've got our Arduino microcontroller, which is basically the brains of the operation. That's the bit that we program, and that tells everything else what to do. We then have our stepper driver, which is powered by this power supply, which is plugged into the mains. That driver then takes a signal from the Arduino, which essentially is telling it what to do, and that driver then powers the stepper motor in time with what it's being told to do. We have a simple LCD display. This just allows us to see in real time what the speed is and whether the thing is turned on or not. This potentiometer, otherwise known as a variable resistor, is just being used for a signal so that we can control what speed we want the arm to rotate at. Now I was going to have a simple little switch or a button that you could turn the motor on and off, but I couldn't really find one, so I ended up using this ultrasonic sensor instead, and I've just programmed it so that to turn the thing on or off you can just wave your hand over the top of it. Now you notice that this is a very simple system with very basic functionality. All we have at the moment is speed control and on and off. That's because when you're developing a system like this with mechatronics involved, the best thing to do, in my opinion anyway, is just to work with the simplest working example. If you want to add programmable functions, for example, accurate position detection, remote control, controlled via an app. Any of these things we can add in later. So let's fire it up now and see if it actually does what we expect it to do. Without the motor on to start with, we're just going to test whether this thing actually adjusts the speed as we want and whether it turns on or off. So if we rotate the potentiometer all the way to the left, we see we have 0 RPM. Now this RPM is actually being calculated based upon the signal that's coming in and then a little formula that I made on the program. So if we rotate this right, you should be able to see that the RPM is in fact increasing, and it should go all the way up to 10. Hand over the sensor, and now it's off. Now let's plug our supply into the mains and power it up and see if the motor runs as we expect. And we are go. So it seems we're able to get up to 5 RPM, but any higher and it cuts out essentially. That could be that the power supply isn't providing enough power, but the fact that it's actually cutting out suggests to me that the driver is telling the Arduino that it can't go anymore, which means that this driver probably isn't up to the task of actually providing enough current to this thing over here. I suspect that once we put a load on this thing, i.e. the weight of the entire rig, this is probably going to cut out even sooner if it moves at all. So I think we're going to have to try out different power supply. If that doesn't work, we might have to get a bigger driver at some point. Hi there guys, first of all, sorry for the terrible echo in here. I'll try to make this quick. It's just coming up to a month now after I actually filmed the video that you just saw. I've only just finished editing. I just wanted to talk to you quickly because as I've gone to upload, I've discovered a video that you might have seen already by a channel called Make Art Now, which has kind of a very similar theme and produces a sort of similar product. Now I don't normally compare what I'm doing to other creators. I don't think that's beneficial. Honestly, it's not really of any interest to me. But in this particular instance, I thought it was important to address it based on the timing, the fact that I started my project within a few days of Josh from Make Art Now releasing his Kickstarter. And if you haven't seen his video, I'll link it below. Josh basically created a Kickstarter of what he calls an orbital rig, which is basically just a better version of what I just made during that weekend. And the reason I wanted to talk about this is because I don't want people comparing the two. It's really apples and oranges, or apple and apple tree, probably. You know, this is what I've built this weekend, during that weekend, really is just a concept. It's a first prototype. It's the sort of thing that Josh was probably making like a year ago. I want to make it very clear that my video in no way attempts to minimize the amount of work that he's put into his product. He spent months, years developing this thing, getting it so that it's quiet, it's smooth, it does everything you need it to do. He's produced a really refined, a really well-developed product. And I hadn't actually discovered his channel before today, but just looking at a couple of his videos, seems like he's doing some really, really great work. So anyway, that's all I have to say on the topic. If you're wondering why it took me so long to edit this video, well, I've been in a process of yet another move. In case you're wondering, yes, I am actually in France. But more on that next time. See you guys in the next one.